All right, everyone. Our goal for this unit was to compare data values within or across populations. And the way that we're going to do that is by using measures of relative standing. These things, the word relative, just helps you to describe how you compare to the whole. And in our first unit, we talked about relative frequencies. Remember, we used percents to help us compare to the whole. That's one way that we can compare, and we're going to use that using percentiles. The other way that we can easily make comparisons of relative standing are with z-scores. So z-scores let you see how far away on average you are from the mean, or how many standard deviations you are from the mean, and a percentile just gives a percent. Cool. So what is a percentile? Let's give that a definition. The definition's a bit ugly, but a percentile is a percent representing the data value for which that percent of the other data maybe I say that percent of other data values are the same or less. Okay, maybe that doesn't make any sense. Let me reread that. A percentile is a percentage representing the data value for which that percent of the other data values are the same or less. So, for instance, if you are in the 80th percentile for the height for people that are your age, you could say 80% of people are your height or shorter. Typically, percentiles are used when you have a lot of data's values. Think about like thousands of data values. A percent is a lot easier to talk about than super big numbers. So the examples that we have are a lot smaller. I already counted these all up, and there are 40 data values in each of these data sets. But regardless, we're going to use those to help us find the percentile. So for the first one, it says find the percentile for 3. So we want to know how many data values are 3 or below. What percent of data values are 3 or below? So when I count that up, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 data values that are 3 or below, and that is out of 40. And so if you were to find that percent, that would end up coming out to be 30%. And I could say that 3 is in the 30th percentile. Or you could go the opposite direction, and it says find the 60th percentile. So I need to find where there are the data value that has 60% of the data values below it. So if there are 40 data values, well, I can just find 60% of 40, and that comes out to 24. So I need to find the 24th value. The 24th value will have 60% of the data below it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, oh crap, 20, 21, 22, 23, 24. I think I miscounted. Let's do it one more time. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I did. Okay. So right here, we could say that 19 is the 60th percentile. Why? Because there are 60% of the data values are below. And if you kind of wanted to check yourself and go in the reverse order, you could do 24 out of 40 does equal 60%. So, lots of data values could be in strings, but most of the time they'll be in some sort of display. They could be in a normal display. And now this one says, what percentile is the value of 40 or 400? So I want the values that are 400 and below. Well, we've been pretty used to that. And if you put on your standard deviations on there, oh goodness, right? Like we could easily go find out what spans from -3 to, or negative infinity up to 2. So we learned how to do that on the calculator quite easily. So we can go to, we have a data value. We know the z-score is -2. And so you could even use empirical rule with this if you wanted to.
All right,
oh,
so
no.
Go ahead and join me on page 5.
All right, so if we come here, we can just go on the calculator and go to normal CDF. I know mine is spanning from negative infinity, and it's going up to -2. And so if I do that, that is about 2% of my data. So I can come back over here and do 0.02, what was it, 27, I think is what I saw. And so we could say, what percentile is 400? We could say the second percentile. The 2.27th percentile. So about 2% are that data value and below. This one says what value, now let's remember this is going backwards, it's actually giving you the value, is the 97th.5th percentile. So from there, I need that area that is that or below. And remember, if they give me the area, that means I can go to my calculator and go backwards with inverse norm. So I can go inverse norm, and I want 0.975, and I want that area to the left. And that'll give me the z-score. So the z-score is, if you kind of look, it goes 1.9599, whatever. If you round that up, that gets you to 1.96. 1.961. This would be one standard deviation away. And it's at 9.6. That's about somewhere in here, right? The z-score of 1.96. I would round it up and say approximately 600 because I'm being lazy. So what value is at the 97.5th percentile? I would say approximately 600 because I'm being lazy. We could work backwards and find the value. I just don't feel like it right now because I'm lazy and it's Friday and it's almost 8 o'clock. Anyways, with that being said, it says you at the bottom, just a note for self for your future. You can use z-scores up here to help you make comparisons. It doesn't have to be a normal distribution. You just have to make sure that they're similar in shape. And then you can compare how far away they are from the mean on average. So that's about it for today. And then we're going to wrap up with some FRQs here in a moment.